Fibonacci sequence is defined recursively as so. So this is actually a piecewise definition. So it's basically, for depending on the value of n, it affects the rule for the sequence. So it's saying that the Fibonacci number, so the term is 1 if n is 1, the term is 1 if n is 2, and if n is anything greater than 2, then the term is the last term plus 2 terms ago added together. So this is a rule for a Fibonacci sequence. So from that we should be able to find the first 10 terms of the sequence, find the sum of the first 10 terms of the sequence, and then part C is a bit more difficult, a lot more difficult actually, by observing that f1 equals f3 minus f2, f2 equals f4 minus f3, and so on, meaning f3 equals f5 minus f4, f4 equals f6 minus f5, and so on. We need to derive a formula for the sum of the first n Fibonacci numbers. So we'll just deal with A and B first because that's quite simple. So for part A, it says find the first 10 terms. Well, it says if n is 1, fn is 1. So the first term is 1. If n is 2, the sequence is 2. So if n is anything greater than 2, so if n is 3, 4, 5, 6, 7, and so on, it's fn minus 1 plus fn minus 2. So if n is 3, n minus 1 is 2, and n minus 2 is 1. So for the third term, we add together the first term and the second term. So that's going to be 1 plus 1 is 2. For the fourth term, we're going to add the third term and the second term together. So 1 plus 2 is 3. And then you should just be able to see what's going on. But that's just to make sense of the algebra. Then actually doing it is really quite simple. So 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13, 13 plus 8 is 21. How many is that? 1, 2, 3, 4, 5, 6, 7, 8. Need 2 more. 21 plus 13 is 34, and 34 plus 21 is 55. So that is the first 10 terms of the sequence. So to find the sum of the first 10 terms, I'm literally just going to add them up. So I don't know, S10 or something like that. So S10 might mean the sum of the first 10 terms of the sequence is going to be 1 plus, I'm not going to write it all down. It's 1 plus 1 plus 2 plus 3 plus 5 plus 8 and so on. So 1 plus 1 is 2, plus 2, 4, 5, 6, 7, 12, 20, 33, 34, 44, 54, 58, 88, 93, so that must be 143. So the first 10 terms add up to 143. Part C is a lot more tricky. So by observing that f1 equals f3 minus f2, f2 equals f4 minus f3, and so on, find the sum of the first n terms. So if we consider our sequence that we had before, so 1, 1, 2, 3, 5, 8, 13, 21, and say I wanted to find the sum of the first 8 terms. I think I've just written 8 numbers. So 1, 2, 3, 4, 5, 6, 7, 8. I want to find the sum of the first 8 terms, and if I observe that this 1, so the first term can be written as the third term minus the second. So what I'm going to do, I'm going to write that down. So instead of writing 1, I'm going to write this 2 minus this 1. So 2 minus 1 plus this next term is 3 minus 2 plus, then it's going to be 5 minus 3 plus, and then it is going to be 8 minus 5 plus 13 minus 8 plus 21 minus 13, and I'm going to have to keep going beyond the numbers that I've got here. So fortunately we knew that the 9th term was 34 and the 10th term was 55. 13th term is 34 minus 21, so plus 34 minus 21, and the final term, the 21, is 55 minus 34, so plus 55 minus 34. Now, if you look at all that, you can see a lot of nice cancelling going on. So this 2 can cancel with this minus 2. this 3 can cancel with this minus 3, this plus 5 minus 5 plus 8 minus 8 plus 13 minus 13 plus 21 minus 21 plus 34 minus 34. And so all that's left in the sum is this term here, a minus 1 and a plus 55. Now remember, we were finding S8, and in this case it was, so it is the 55 was the 10th number, so it equals F10 minus, and your 1 was this, it's this second term, isn't it? Because remember, it was 2 take away 1 to get the first term, so minus F2. And that calculation should work to give me this, the sum of the first 8 numbers. So 55 should add up to 54. We could check that just by adding them up. So 1, 2, 3, 4, 5, 6, 7, 12, 20, 33, 34, 54. So it works. Now, we've not been asked for the sum of the first 8 terms, we've been asked for the sum of the first n terms. But if you think in terms of this sequence, you had, so this 2 minus 1 is F3 minus F2. The next 3 minus 2 is F4 minus F3, and so on. So we have all the way up to, you've got Fn equals, so remember F8 was F10 minus F9, so Fn must be Fn plus 2 minus Fn plus 1. So the way this cancelled, everything else, if you think of Fn minus 1, would have been, you shift them all this way, so it would have been Fn plus 1 minus f of n, and then if we shifted it 1 minus 2, we'd have an f of n. So basically, even up to that point, everything cancels. What will be left is Fn plus 2 and the F2, the second term, because if we start to add these things up, you would have F3 minus F2 plus F4 minus F3 plus F5 minus F4, and so on, plus Fn plus 2 minus Fn plus 1. So basically, everything would cancel off apart from this and this. Everything else, you can see, has something. The F5 will come from the next bit, what will be 6 minus 5, and so on. So for the first n terms of a Fibonacci sequence, Sn equals Fn plus 2 minus F2. And that is the expression. Makes things a lot easier.